Good evening. Hello, everyone, and welcome to the August edition of the React Native Meetup London. Apologies for the delay that we've had. We've just been sorting out a few technical issues, but we should be good and ready to get underway pretty soon. If anything, all I see is more hype caused because we know we've got some incredible talks this evening for you. From a legend of the game, as well as a new up-and-coming stalwart of the React Native community. So I'll just give you guys a few minutes for everyone to filter in, and hopefully we should get started soon. You can see everyone kind of filtering in at the moment. So yeah, thank you everyone for bearing with us and waiting through this time. But we should get started in a couple of minutes. Cool. Whilst we're still waiting for a few more people to filter through, I can get started. So yeah, welcome again, everyone, ladies and gentlemen, and thank you for bearing with us. But welcome to the August edition of the React Native Meetup. Just before we get started, as always, a word from Theodore UK, who are your hosts for this event. At Theodore UK, we are full-stack software consultants who are experts in agile and lean. We work with everybody from early stage startups to full Fortune 500 sized companies and everything in between. Our tech stacks involve React Native, React, a bit of serverless, Django, and as well AWS and GCP. So we really work across the whole stack, from everything from MVP products to full scale larger applications as well. And obviously, we love React Native. And just like everybody else, we're hiring as well at the moment. So if you like what you hear and you'd like to join us, please do get in touch with me, Leo, or Ben, and do send your CVs through. Or you can always email us at joiners@theodore.co.uk. So a new announcement for this week, or this month, I should say. We've got a blog up and running as well, and we'd love to hear any feedback that you guys might have about it. Someone should send the blog link in the comments below. But yeah, if you scan that QR code, it can take you to our curated publication. And if there is any interest for anybody who wants to send in articles that we can send along to our lead editor, you can also get published in our Medium publication going forward. So yeah, please let us know how that is, and we're glad for any feedback. Speaking of feedback, as always, I'd love it if you guys could take 60 seconds to just fill in this QR code or link. And once again, the link should be sent through in the comments. every month, sorry, we put this meetup on so that you guys can have great React Native cutting edge content to include in your projects, whether personal projects or company-wide projects, and everything else in between. So if there's anything specific you'd like to see, if you'd like to sponsor an event, if you're a company that's looking to increase your professional profile in the React Native space and you're looking to hire React Native developers, this is a great place that you can come and promote yourself. So yeah, please do take a couple of seconds. It's a really, really quick feedback form, and it really helps us to improve where we're going month on month. So without further ado, I'm very, very happy to welcome our first speaker, Valentin Nagacevschi. He will be talking about how to use Axios like a pro. And so yeah, over to you, Valentin.
Hello, guys. Thank you for having me here. It's a real privilege. Today, I'll cover the topic of how to use Axios with serious, secure, bank-grade APIs. Almost 1.5 years back, I joined 10x. 10x is a fintech company which is providing banking solutions, cloud native, essentially a bank operating system. So in order to interact with this, let's say, bank operating system in the cloud, the only way is to use APIs. These are, let's say, serious, secure bank grade APIs. So starting to build a mobile application for such, demands, we had to cover a couple of things. And this, I summarize here some requirements for any modern API client. So first of all, the ability to have a persistent headers configuration, token-based authorization, token expiration and refreshing, idempotency fingerprinting, we'll get to that, and multiple base endpoints. So during this slides, I will show you, I will dive you in the code to see how we can build an API connector which can fulfill these requirements. So from now on, almost only code will be. So yeah, I hope you'll enjoy it. So how does API connector look like? Essentially, it's just a function which is returning a single function, and this function is a get instance function. And if you see, the get instance is pretty simple, and it's returning just an instance if it's found based on its name, which can be the default one, so you don't have to worry about if you have only one instance or you have the default one. And if the configuration is provided in the get instance, then it will create a new instance. This can be used also to override an existing instance, obviously. So let's see how this create instance look like. As you see above the line 2, we have a set where we are storing multiple instances by name. And let's see the way to use it first. So in order to use the API connector, you have the first part is the initialization. So that's the configuration, and we're getting the new instance as a default, and we are providing a set of value pairs. Some of them are Axios specific, like base URL, and some other are, let's say, specific to our API connector, and we're going to see the use of each of them. And also, it's very important, the two flags, the auto refresh token and the use idempotency tokens, which are very important and will trigger some interceptors, but we'll see later on. So the way you use it, the connector it's initialized, you just straightforward using as an API, or anywhere else in your code you can call it with API connector get instance, or maybe if you have a different instance with, let's say, the name legacy already initialized, then you can call it anywhere with get instance of that name legacy. So that's very easy. The most important part is that with this API connector, you just focus on the task at hand, calling the post and get and whatever patch you have to do, without worrying about the authentication token, the idempotency, and other things. So everything else is happening under the hood. So we're going to see how these things are done. So the first part, the create instance, we're just separating the Axios instance from the rest of the parameters, and we're going to create the headers. This is the initial default headers for our instance. As you see here is a very, let's say, a smart way of providing the headers only if the values are different than undefined. Because if you just write the header and the value which is undefined, the Axios is transforming the undefined in a string name undefined, and then it will provide the header with the value undefined, which is strange. Once we have the headers, we're going to use the factory to create the actual instance. And here we have an example of using two different factories: the original, the Axios factory, and the debug web Axios. The debug web Axios is here just for to illustrate a way to use the Axios factory with a specific or a custom adapter, but we're going to see them at the end. So here, as you probably notice, we're going to have two different instances. One is a refresh instance and one is the instance. They are looking identical. The only thing is that the instance is casted to an extended Axios instance because we might need this kind of type later on. Why is that? Because the instance headers will, during the life cycle, will be updated. And will be dynamically updated. So we don't want to have the refresh instance polluted with let's say, specific headers from the instance. We're going to see why is that it's important. And once the instance is created, we're just going to add it in the set of the instances to be retrieved later on. Once we have this, we are going to use the interceptor. The interceptors are very important and very powerful methods which are provided by Axios. And we have two types of interceptor: the request interceptor and the response interceptors. For the request interceptors, we're going to use two. One is the authorization interceptor and the other is the idempotency interceptor. Axios is using these request interceptors in an asynchronous way, not to, let's say, block the request. However, we want to block and alter the request. So this is why we force the synchronous to be true, the flag. And we also provide the run when, and we're using the flags, which I mentioned in the configuration, the auto refresh token and the idempotency, using the idempotency flag. So only this interceptor will run only if these flags are set to true, right? The response interceptors where you're using two. One is a store token interceptor, which will be called on success of the request, and the refresh token interceptor, which is called on the failure of the request, right? So we're going to see each of them, right? So the first interceptor, the authorization interceptor, is essentially just adding an authorization header with the bearer and the token, the access token, which is stored in this object, the tokens object. So this token object is storing the access token and the refresh token, right? So if this access token value is present, then automatically the authorization header is added to the request, to each request. So this is a way to make sure that once we have this, once we logged in and we are authenticated and get this access token, all the subsequent requests are, let's say, provided with this authorization header. The next interceptor will be idempotency interceptor, but let's first, let's say, recall, or maybe for those which do not know too much about this idempotency. So the idempotency is the mechanism to try to prevent repeated accidentally requests. For instance, if you want to do a payment and you get a timeout, you don't want, if you retry the payment, you don't want this payment to be done twice, right? So for that, it's important that some of the methods called on the Axios to be idempotent. Now, from the literature, from documentation, the idempotent HTTP verbs are get, head, delete, and put. I said put on red because there are APIs which are also not trusting put as an idempotent. The put normally is used to overwrite or update an information. So if you provide it twice, it doesn't matter because you keep updating the same, let's say, object twice. But sometimes the put is used by the server side in different ways. So this might be a case that put might also fall in the non-idempotence verb. So the idea is to provide a key, which is a unique key, and the format, the preferred format is UID-v4, also used, for instance, by Stripe. And this key is just a fingerprint which is generated from the payload data, right? Like a checksum. So we're going to see how this is happening. Now, the idempotency interceptor, it's very simple. It's just checking the method of the request, and if it's either post, put, or patch, it will add the idempotency key from the payload, from the request data, right? Let's see how this idempotency key from method is designed. You'll see probably here a lot of math. I'm not going to get into much detail. The only important thing is that the build hash, the function below, is providing a 16 bytes hexadecimal string. And it also provides a very widespread, so the chance of collision is very low, extremely low. And we need to have a UID, we need a 32 bytes hexa. So what I used here was to first build a hash from the payload, and the second hash was built up from the previous one. So we have a pretty big spread here. The response interceptor, the first response interceptor on the success is a store interceptor, and this is only checking if the auto refresh token flag is set to true. You remember that flag. We're going to inspect the data, and if this data contains the access token and the refresh token, we're going to add them to the object tokens. This is happening when you, for instance, do a login and you get back the tokens for the request, the access token and the refresh token, but those are automatically, processed and stored in the API connector, so we don't have to worry about it. Once they are populated there, let's say the interceptor for the request interceptor will always populate the access header, right, with the bearer for the access token. The second interceptor, the refresh token interceptor, if you remember, it was triggered only on error. So when the call was failing, and if this call is failing, we're going to extract the status and the data from the response. And if the status is 401, which is unauthorized unauthorized request, then we're going to try to refresh the token. First, we're going to check if we already retried, and if we retried already and we failed, then we're going to fail anyway. If not, we just set the retry to true, and then we're going to call the refresh token. And this refresh token function, if it succeeds, we're going to retry the original instance, right? So the original instance which we are working with. And if it's failing, we're just return the error, right? The refresh token is, as you see, is using the refresh instance. So right now, it makes sense to have two instances because this instance will not be polluted with any other, let's say, headers, which are not necessary there. And also let intact the original instance, which is used to retry the original request, right? So if the refresh token succeed, we're going to receive the access token and the refresh tokens, and we're going to store them as usual, right? So this refresh token is also used as a helper function, and along with another helper function, which is the update headers. And this update headers function is used to update in sync both the instance and the original instance and the refresh instance, with additional headers if the case. So these two headers, these two methods, the refresh token and the update headers, are added to the instance. So that's the reason the API connector is returning an extended Axios instance as opposed to a normal Axios instance, because we want to have access to this refresh token and update headers functions. At the end, we're just returning the instance, so then everything is fine. Now, because we can't overlook the TypeScript part of any code when we're talking about React Native, here is some types. So the connection config is just an extension of the Axios request, and we have a couple of data there, like API keys, device keys, and so on, and also the two flags, which are very important. Then the obvious headers type, which is just straightforward key value pair of strings. The extended Axios, which I talk about, and it's an Axios instance extended with the refresh token and the update headers. And then we have to also handle the did retry thing, which is added in the config. So for that, we have the next two types. And at the end, we have the type for the object, which is storing the access token and the refresh token, right? So remember that we were talking about different factories. So we have the Axios as a normal factory to create instances, but we want to see how we can use a custom factory. So this is, let's say, this debug web factory Axios. It was called debug web Axios. And the purpose of this is to add the React.run debugging when you want to run the React native application in Expo in web, for instance, right? So then you want React.run is not able to intercept the Axios calls. So how are we going to do that? The normal create function is just using the Axios to create a new instance but with a different adapter. So see the before last line, and then we just return this this line. But let's see the adapter, how we create a new adapter. So this new adapter is using the original HTTP adapter from Axios library, and is just intercepting the response. And if this response, and if it gets the response and the debugging is true, then we're going to call this function, which is debugtron, and we're going to provide the request and the response for that request. Otherwise, we're just ignoring it. And at the end, we need to call the settle function, which is also provided by Axios, to make sure that we settle the resolve and reject with the response. So that's a very simple adapter, but obviously you can use the HTTP adapter from Axios, or you can build your own fetcher and build an adapter using your own fetcher, for instance, if you have something like an encryption, right? So so how this debugtron is using, essentially it's calling the reactortron API response, or a reactortron API response, which is line 5, and it's tronifying. Okay, so it's formatting, it's transforming the config and the response for the understanding of the reactortron. I'm not getting into too much details with that. I will share this code shortly after this session. So we kind of ended the hard part with the code. So let's go and remember the features of the API connector. So we maintain multiple reusable pre-configured Axios instances, automatically provide a dynamic authorization token, store internally the authorization refresh token, ensure automatic authorization token refresh, retry the failed original on authorization, build idempotency fingerprint for post-patch input, and provide support for Axios Factory's current adapters. So this is all. If you have questions, I'm looking forward to answer that. Thank you.
Thank you for that, Valentin. Thank you for that awesome talk about Axios and using it like a pro. Really cool to see you dive into the details of this API connector, which I'm guessing is something that you've custom built, right, completely for your applications. But I guess it can be used across a range of different products and projects. So yeah, that was really cool to see. I will take some questions that come in through the YouTube or through the meetup. They'll be passed through to me. But first, before anybody else gets a chance, I have some that I want to ask you personally. So I'm going to abuse this position that I have to ask you all the questions that I want to. So yeah, firstly, it seems like a good idea maybe to make this into an NPM package so that other people can also use it. Is this something that you've thought about maybe, or something we might see, or no?
Yeah. Oh well. At the first, I was thinking of having it in the NPM package. However, I remember I stumbled upon a project where let's say, for instance, the access token and the refresh token were served not in response but in the response header, which was very particular. Probably somebody was thinking this is more secure and hackers don't know about the response headers. But so this is why I will probably release this code, just as a repo, so anybody can tweak it and adapt it to their own use, as opposed to an NPM, which is you need to patch it and it's more complicated, right?
Right.
So yeah. That's the reason I don't want to make it as an NPM package.
NPM package, of course. So just like a custom GitHub link on your repo.
Yeah. Yeah,
Cool.
exactly. So they can just take it and use it and modify it based on their requirements.
Cool. Do you have a rough date that you might want to put this up, or rough time frame? Because I think this will be a popular one with our followers.
Uh, I'll try to do this by
Oh,
Thursday next week.
yeah, no, there doesn't have to be a rush or anything.
I hope you,
absolutely.
I hope you didn't expect to have it
No,
by
no,
midnight or something.
Oh, I thought it'd be ready already, but it's not. So,
Yes.
oh, but it's a good problem to have. But yeah,
Right.
we've got a question that's coming from the audience, which is, what was the most difficult part to get right of the adapter, would you say?
The interceptor, the refresh token interceptor is the hardest part because you really need to to get the support, a strong support from the server. So it's harder to mock this server requests and responses. So really, it was a little bit tricky to develop. I mean, the logic was there. It's just it was harder to to implement it because of the testing part.
Right.
And also the idempotency part, the fingerprinting with this, because I was looking for a very fast way to get checksum from whatever payload, just delay the request just because you're making a MD5 or something more strong, but very, very time consuming, right?
Right. And yeah, testing can be quite tricky, I guess, especially with the refresh tokens and things in general anyway. And so on top of that, yeah, you can imagine this was kind of tricky to do. But yeah, I've got another one as well. It's coming. There are a lot of libraries out there on NPM and otherwise for adding a client to your React or React Native project. And a couple of these are Super Agent. You have the Axios library that you used, Super Agent, as I said, and then there is also like React Native's inbuilt fetch API, right? Is there any reason you chose to use Axios to build this on top of instead of the other two? And what's your thoughts in general on the other two?
Yes. So because we're in using bank grade APIs, the normal way to connect is not the standard way, but we need more secure way to connect, and therefore we had to build a custom adapter, which is providing extra security and extra encryption.
Right.
Right.
So would you
So
say
this is
that?
why this is why I was having the last part, how to build a custom adapter. Obviously, the reason is not only for debugging, but if you want, for instance, to add a custom fetcher, which is a native component, which is doing some strong encryption on top of whatever it is, so you don't really use the Axios, but as a wrapper for everything, but the fetcher inside in the adapter is a very custom one, which is, as I said, doing very strong encryptions, right? Or certificate pinning, or I mean, there are a lot of things which are, let's say, normally, below the radar of most of the programmers, right? Because not everybody is dealing with high security APIs, right?
Yeah.
So that's the reason.
Fair enough. No, that makes sense. Cool. So I think that's all in terms of questions. Thank you for answering them so thoroughly and well. I think now we can move on to our second talk of the evening, which will be from Benjamin Gowers about how to create an audio show for 15 million plus users. And that is not a typo. It's not actually just 150 or 15,000. It's 15 million. So yeah, looking forward to this one, Ben, and take it away.
Thank you. Okay, thank you so much, Arahan, for that amazing introduction. And yes, it's not a typo. 15 million plus users. That probably is the cap. But yeah, I guess I should introduce myself. I'm Ben. I should. I'll be talking to you about how I created this audio show, some of the problems I faced, and these kind of things. So, going more into the agenda, talk about what it was I was making and why. And then I'll talk more about sort of the functionality, so the user interaction and some of the edge cases that are good to think about for this this audio show. Some of the challenges I faced, and more specifically, the sort of automatic opening, so the polling for this audio show, the state management, how I specifically managed the state for this feature, how I consumed the audio data as well, and how this was done natively. And then we'll take a quick look at some of the code and a little demo of an audio show that I've mocked out. So yeah, going into the audio show, what actually was it? You know, why was I doing this? And it was basically a feature on a companion app for a large sporting event, which meant that, you know, we had 15 million plus users, like so many users. As I said, that was probably the cap. It was probably around 2 to 3 million most of the time, but that's still a lot of users and a lot of requests to manage. Also, it was a multilingual app, so I can't remember exactly how many, but there were probably about 10 plus locales that we had to manage. I won't be going into this, but it's just worth mentioning. So yeah, what should this audio show do, and what is it? What does it look like? First and foremost, it should play an audio track. It's you want to press play and you want to hear a track. It could be music, it could be a podcast, something happening live, or something just hosted on a server somewhere. We should be able to see our track name and description, just information for the users. And from a more interactive point of view, we want to be able to play, stop, and close the audio show. And some of the constraints on this project that I had. So this audio show was only accessible in English. So we need to think about, we only want to display it when our device's language is in English. And we also don't want to melt the server that we're accessing, right? So yeah, as I said, up to 15 million users or maybe more. That's a hell of a lot of requests. We don't want to be smashing a server with that and just burn it out. And then finally, a user should be able to hear the audio show after a maximum of 30 seconds. And that's because with this audio show in particular, there was a 30-second gap at the beginning where there'd be music playing. After that, we actually get into the meat of the audio show. So that's when we want the users to be able to hear what's going on. So with those in mind, I'll talk about some of the functionality of the audio show. And this might be quite simple, but it's good to think about. So opening the audio show, we've got two different ways of doing it. The first of which is manually, and you can split this up too. So one of them's in the app. You press a button which says open my audio show, it's live or whatever. Or a deep link, we have a notification sent through to the phone. You press on the notification, it opens up the app, and we see our audio show. And the second of which is automatically. So while we're using the app, if the audio show goes live, we want the user to be able to see it. So yeah, let's talk about how we actually do these things, or some of the things we need to think about when doing these things. So manual opening, is definitely the simpler of the two. So you press your button, the audio show comes up. And your edge case is what happens if you press your button when your audio show is not live. You need to show that the audio show isn't live to the user. Plus the constraint that we have on language, we want to say your language is not English, so that they know they can't access the audio show. Obviously, this will be translated into the language that they have on their device. The second of these opening methods, which is probably the more interesting one to think about, was the automatic one with polling. So just very briefly, polling, if you don't know, is just doing requests in X time increments repetitively. So this was the architecture that we used for our audio show. We had our app, which is the front end. We had a cache server and a backend that costed per request. Cache server was sort of a dedicated server for just hosting the audio show metadata, or not if it wasn't live. So how this actually worked, the cache server every second would be polling every second to see if the audio show was live. If it wasn't live, that's fine. The cache server doesn't hold any information. Then some external functionality updates the audio show being live in the backend. Now, next time the cache server polls, or the next second, it grabs the audio show live data. Now the live data is in the cache. So how do we get this onto our app? We get the audio show every 30 seconds. So that's times 15 million, because we could have 15 million users. That's a hell of a lot of requests. If it's not live, then obviously we don't get anything. If it is live, we get the audio show. The interesting part about this is just, why did we have this cache server in the first place? So that one of the reasons is the cost. If we're doing 15 million requests every 30 seconds, we'd be doing 30 million requests a minute compared to 60 requests a minute. Also, this is a hell of a lot more scalable. So if we have a dedicated cache server, that server only has to deal with the requests from the phone and for the audio show, whereas this backend is for our entire application. For all the other functionality, we could get blocking and melt our server, as I mentioned. So it's good to think about what could go wrong with this polling, and this is more from the point of view of doing the requests. And the first one is obviously language. We only want to get the audio show if our device's locale is English. That's an easy one. We can just check the locale on the device before we start the polling or do the polling at all. And another one to think about is, what if it's already been opened and then the user has pressed the close button, but our polling is still happening in the background? So we don't want to reopen and re-show the audio bar. So basically we say, when we're receiving data from our request, which happens every 30 seconds, we only want to update the state, or whether the audio show is showing or not, if there isn't already data in the state. And this is because when the audio show isn't live, the state is empty, right? So I guess this leads on nicely to the state management for the application. So this is kind of how I manage the state. Obviously, there's different ways to do it. But if we just sort of say our audio show data is coming from the backend, that would be our cache server. It's coming into our app. I chose to use Redux to store this, mainly because the rest of the application was actually using Redux, but we created a nice audio show slice. This then fed into an audio show context, which was kind of the sole source of truth for our audio show, which meant that any component that needed to use the audio show data, metadata, which is title and description, only needs to access this data from the audio show context. And then, of course, we have our React Native track player, which I'll talk about a little bit more later, but it's the part that helps us consume our audio data and give us native controls for play and stop. That can be contained within the context as well, and therefore forwarded to components or consumed by components that need it. So a little bit more about the Redux. Why did we actually use Redux? It just made it really nice to be able to store the audio show metadata from the backend. This was the type that we used for our audio show. So you can see it's pretty simple. We can have our initial state. So when the app initializes before it's polling or anything, we always have an empty audio show and we can signify, to the user there's an error, or it doesn't exist. And when our audio show populates, that's kind of what the data would look like there. We also have state in Redux for our opening method. And this probably seems a little bit weird because a user can just press a button and open the audio show, right? But this is mainly for, if the user is pressing a button and trying to open the audio show when it's not live, we want to show an error message. But we don't want to show this error message or toast when we have the audio show not live from the polling or the automatic opening method. Hence, we always switch to auto, so we don't show an error message. And as soon as they press a button in the app, we switch to the manual opening method, show the error message, switch back to auto. So yeah, a little bit more on the audio show context and why we actually used it. As I mentioned, it's sort of a single source of truth for the audio show. So we can expose everything that we need to expose to all of the components that consume things about the audio show. It interacts with both Redux and the track player. So sort of linking back to the single source of truth, everything you need for the audio show is contained within the context. And we can contain all of the business logic for our audio show in this context. So this is an example of the opening method that I was just talking about. So yeah, we can switch to manual, show an error message, and then switch back to auto. And then finally, I guess, consuming the audio data. So talking more about the React Native track player and why I actually decided to use that. So it has an easy to use API. As you can see from some of the code there, it's just 3 random lines, but it's pretty obvious what that's doing. We have remote events. So this package sort of really nicely managed the native side of the audio playing. It didn't try and do some sort of hacky JavaScript way of playing the audio through that. It would actually use the native audio players. Hence, you could use background audio, put the app in the background and have the audio still playing. And another sort of small one was the track types. So you could define which type of track was being consumed to React Native track player. And this was useful because we were actually using HLS. So because it was a live stream of an audio show, you can tell React Native track player that this is the kind of data that's consuming, and that will work properly natively. If you don't define that properly, it just crashes. So yeah, let's move on to the code and the demo and have a look at some of that stuff. So hopefully, if I just slide over here, you can see my screen still. Okay, there we go. Okay, sorry about that. I think I was just sharing the wrong window. So yes, first I will take a look at the code, and then I'll move over to sort of giving a little demo of the app and how that works. But as you saw, we have the audio show type. So this is everything that will expose from our context. By the way, this is our audio show provider. So this is our context. We have the initial value, so it's pretty standard stuff. And we create a little hook for consuming the audio show. It's a little bit easier. We've got a bit of setup. It's useful to see that we wait for the buffer there. This was a little bug we had and didn't know how to solve for a little while. But yeah, it's a bit nicer being able to wait for the track to buffer ahead of time a little bit. Also the capabilities. So this is what we can actually do with the React Native track player, and this is what we can do remotely. So we could add pause or other things these were just the functionalities we needed. And moving on to the actual provider. So you can see that we access, the playback state from this is from the React Native track player. We have data from Redux, and we can sort of derive the live and playing states from this information. This was this little user effect about the manual or auto opening methods, whether it's polling or the user has pressed the button and showing this toast error message. This is quite interesting as well. So after we've actually registered our remote events on our app start, we want to consume those remote events and make sure that we actually react to them. So this is just a remote stop, pretty simple looking code, but it's useful to know. We have a play and stop methods, our store, and finally returning our provider. So we can wrap that around any components that we need to consume that information. So this is pretty much the meat of everything we need for our audio show. Obviously, we've got our components that are just styled and rendered and consume functions and data from this. So I've sort of mocked out a go live button. Obviously, this would happen if the audio show was being polled for. But if I just click this here, you can see the audio show appears and we have some of our functionality. If I close and reopen, we can still open up our audio show. I'll play a track. Hopefully it's not too loud actually. I don't know if that audio will come through anyway, but whoops, I just lost my simulator. Can't seem to get that back on the screen.
Yeah, you might want to just go ahead.
Let's just grab that. Let's just grab that back. Let's see if I can start it up here again. Reshare. Sorry about this, everyone. I'm just trying to get this back again. Okay, I think we're almost there. There we are. Perfect. All right, so we're back again. We have our audio show still playing. I can actually hear the music. So I was just going to do a little demo of how we can actually close or put the app in the background. We have our audio show playing natively sort of in the background. We can stop this. It won't just yet. So if I go back to the audio show, you can still see it's playing. We have a nice little Lottie animation. If I stop this remotely, we can see that the audio show stops and disappears. That is still online as we can open it back up. If we go offline, it stops. And if I try to open it, we get a little notification saying the audio show is not live. So yeah, that's sort of a little demo, and that's some of the code. I can try and submit some of the code back up to GitHub for you guys so that you can take a look at some of the other components and how they consume that information from the context. So yeah, let's go over a little recap of what I presented to you guys and what we've looked at. So I think an important thing about this is why I was building it, and I guess it's mainly because of the number of people that we're going to be using this. 15 million plus people is a lot of users. We've talked about some of the constraints and capabilities, some of the things we should think about when designing and building something like this. also talked about how not to melt a server, right? So a little architecture that you can think about and set up so as not to destroy your server. We've talked about organizing the state for the audio show. So that's mainly revolving around the audio show provider, so the context. And we've taken a look at some of the code. So yeah, thank you very much for listening. And I hope some of that was interesting for you. And yeah, if anybody's got any questions, feel free to ask now, and I will answer them as best I can. Thank you very much.
Thank you so much, Ben, for that amazing talk. I'm not going to lie, as soon as you mentioned the 15 million users, then it might be a sporting event, my mind was whirring, but I probably don't want you to go past any NDAs that you may have signed. So without further ado, let's get into the questions. Yeah, really cool application, and I've got a couple for you just off the bat. Could you tell us a bit more about how you implemented the deep linking system that you said? Just, there might be a few users who haven't done a lot with deep linking before. And I guess it's primarily for notifications.
Yeah, so I didn't actually do too much of the deep linking side, I've got to admit. I think it was managed mainly by Firebase, and then we could react to events through that. But yeah, I'm not too sure on that one. Obviously, I think the deep linking was through notifications on the phone, which there's a pretty good API for, just from React Native anyway. And then through sort of web links as well. But all of those, I think, would post to a Firebase server or database. I'm not too sure. And then we could react to events from that.
Fair enough. There's another question here as well. What are the streaming types, etc., and why did you use this? From Liam Brock. And I actually had a similar question. I saw that you had HLS as one of the types, and I think I'm just a bit curious about that.
Yeah, again, I haven't done too much research into what the streaming types were. I think HLS is actually, it's sort of or you can use it as a wrapper for MP3s. So you can basically stream an MP3 track through HLS. I think.
I think it's the kind of live streaming across HTTP, I believe. So yeah, that must have been cool to work with, right? Because there must have been a whole set of different challenges trying to do a live streaming audio event instead of just playing like a .mp3 file, right?
Yeah, well, you would think that is something that I thought was going to be a challenge, but actually with the React Native track player, it was as easy as just adding the track to the player.
Oh, really?
And it would handle it. Because we had a server where the track was being hosted, basically the track player would be playing from that server, but the server would be ahead of the track player. So the track wouldn't end until you end the stream on the server. And therefore it's treating it almost like a normal MP3 that just gets longer.
Gets longer continuously as you go.
Yeah.
That's pretty cool, actually. So I guess you had, do you sort of set a link or something that the track player has to keep querying from?
No. So I guess, the link, it would be querying from that link. But one of the properties of the audio show metadata that we get back from the cache server was the audio show URI. When you provide that to the track player with the type of HLS, it manages streaming that URI. Basically.
Oh, I see. Awesome. And I know you are more on the client side of this, obviously, than the server side. But did you have any say or insight? I might be prodding a bit here into how the HLS data was generated on the server side.
No. So we we spent quite a long time trying to think, how do we actually make sure we know when the audio show is live, right? So we thought of a few different ways, or at least I was thinking of a few different ways about long polling, so keeping the TCP connection open, or could we have done WebSockets? But both of those methods are quite resource intensive. So
more so than polling, you'd say?
Sorry?
More resource intensive than polling, you'd say, for this use case?
Yeah, definitely. I mean, if you're doing long polling or WebSockets, you have to keep a connection open, and that's sort of staying on the RAM of the server, right? Or the memory of the server. So if you have 15 million WebSockets open, that's going to be taking up a lot of memory at one time. Whereas polling, you're just doing one request, get it back. I know it might be 15 million every 30 seconds, but it's only...
It's an instantaneous poll that goes and comes out and comes back, right?
Exactly.
Because that's the other thing that you might, as a developer, think if you want to go for a high-profile event, high performance, you want to use WebSockets, right, to get that real quick, low latency feel. But I guess in this instance, it's actually way more efficient and better to go for a polling system.
Yeah. I mean, I guess clients sort of accommodated for the fact for that by putting 30 seconds of just jingle music or whatever at the beginning, so that our intervals of 30 seconds was the latest it could have been to hear the track.
So even if you just miss the poll, the next time it comes through, you will still hear that 1 second of music before the event begins. Nice.
Exactly.
That's a nice little design implementation.
Yep.
Got another question here.
Nice.
Would you say Redux was justified for your state management, or would React's use context and auth context, would that have maybe done the job? Or did you inherit a code base that already had Redux, and so
for the mock application that I made, I probably could have done without Redux, and if it was me doing this from scratch, I would have done it without Redux as well. Especially because we use the context, right? So we could have also managed all of the state just in Redux and not use the context at all. But yeah, I think, in my opinion, it would have been better to do it without Redux. It's just that the code base was a big existing code base that was already using Redux. So it was better to consume the data from the API into Redux, as this was sort of a standard for this project. And then we could isolate everything inside the context and just have our own little slice and feature for the audio show.
Yeah, that makes sense. I mean, you don't always, you don't want to mess up an existing massive potential monolith just for one feature. Got another question that's come in. What happens when other sound making events, such as phone calls, text message notifications, or any other notifications happen during a broadcast?
So, I mean, I never actually tested this. I never manually tested this, but because the React Native track player is handling the audio natively, it would handle it just the same as if you were playing something on Spotify and the notifications came through. So I guess it would sort of play both
sides. I mean, that makes sense.
Yeah, that's my educated guess at that part.
No, that's fair enough. And yeah, final question. You mentioned that this was only for English-speaking users. Do you have any thoughts on like how difficult would it be to add an extra language or a secondary language, or is that more of a business logic question?
I mean, it's kind of both. So it's mainly just it's the opposite. It's not that it would be hard to add. It would be really easy to add because we have the constraint of it being only in English. So there's literally code that says, if not English, don't poll or don't show them the audio show. So if you get rid of that, anybody can listen to the audio show. Obviously, you need to change stuff in the back end as well. But on the client side, it's very, very easy to add languages because it's a constraint rather than something that you've sort of built
into the system. Cool. Amazing. Well, thank you so much for that talk. I liked how you ended it with this is how you do it if you want to do it yourself. If I want to build an app for 15 million users on a Saturday evening, then that would be really good. I will use context if that ever comes up. But yeah, thank you so much, Ben and Valentin, of course, for both your incredible talks tonight. Really enjoyed this one. It was really different, you know, one talking about audio stuff, one about Axios. And I think there's something there for everybody today. So yeah, thank you very much, guys. And until
Thank
next
you.
month.
Thank you.